Alright, today is March 23rd, 2018. Test will be Monday of next week, which will be March 26th. So just so that you know, and because you will probably talk to people before I will, if you see somebody that's not here today, I'm posting this video so that they can do the same review along with the worksheet. So just let them know that they can get to it and they can follow along with it. Not right now, but they'll hear me mostly, not y'all. The mic only picks me up. All right, so our opening question today has to do with predicting products. I'm going to tell you straight up, on the test, I don't have you do a whole lot of predicting, only a couple. At predictions, and when we're looking at predicting the products, what we need to be able to do is just kind of figure it out. There's only two types of reactions that we can predict for. That is single replacement and double replacement. So looking at this question, it says write a word equation for this reaction, and we need to predict the products as well. So we have solid magnesium and hydrochloric acid, which I actually gave you the formula for. So the word equation is, actually we don't even have to do that. Let me erase. We don't have to write the solid, we just go, we have magnesium plus hydrochloric acid. This is not the sheet, this is just the outcome. All right. Now, at this point, that's all the information we have, right? So what we need to think about is what type of reaction is this? Is this single replacement or double replacement? Single. It's single. All right, so since it is single, we need the activity series. That, what is it, table J that I gave y'all the other day. All right, so according to table J, magnesium is above hydrogen, so what's going to happen is magnesium is going to replace the hydrogen. And so let's just go ahead and do the formula equation as well. What's the symbol for magnesium? Mg. So I'm going to say Mg plus, what's the formula for hydrochloric acid? HCl. HCl. All right. I can go ahead and fill in that magnesium's a solid, and I'm pretty sure that hydrochloric acid is going to be in an aqueous solution. So now when I'm writing the products, what is the magnesium going to be connected to now? Magnesium makes what kind of ion? Does it make a positive or negative? Positive. So it's going to replace the positive. Chlorine's always negative, so it's going to go magnesium and chlorine. Now, what is wrong with my chemical formula for magnesium chloride here? I got to do the crisscross. What charge does magnesium normally have? 2. What charge does chlorine normally have? 1. So where should I put my subscript 2? After chlorine. All right. And then we're going to have hydrogen produced as well. Well, what's wrong with my hydrogen here? It has to be 2 because hydrogen is part of Brinkelhoff. These are all diatomics. All right, so that means I have 2 chlorines, so I need a 2 right there. That's balanced. All right, so finishing my word equation, I'm going to say magnesium plus hydrochloric acid yields magnesium chloride magnesium chloride plus hydrogen gas. I can put a G. All right, so I'll put a G right here just to let that know, and then I'll put an AQ here just so that goes. All right, so the thing that I want you to understand is prediction is fairly easy. All you have to look at is if it's single replacement, we're going to use that activity series. We're going to use that table J. You'll be able to have it out during the test. If it is double replacement, so let me do this real quick. Let me insert a page. Where is it? Zinc is always going to be a +2. All right, let me find, how do I insert a page? Where is it? So let me show you one for a double replacement reaction real quick. All right, so let's just take hydrochloric acid, HCl, plus sodium hydroxide. All right. Now, so this is a double replacement reaction. What we are looking at here is, guys, pick up whatever needs to be picked up. All right, so double replacement reaction, all we're really going to focus on is the metals. The metals are going to switch places. So anytime you have a double replacement reaction, you don't have to worry about activity series or anything like that, is the cations will trade places. So hydrogen and sodium are going to trade places. So we end up with hydrogen hydroxide, which, what's the other way that you know this formula? H2O, which is water. All right. And then we end up with sodium chloride. All right. Hydrogen acts as a cation. So it'll act as a positive ion most of the time. All right. So all we do, anytime that it is a double replacement reaction, and I'm asking you to predict, you just replace the metals that are in that first position. Whatever positive ion that's in the first position, you just trade their places. There's nothing really to think about or stress about with predicting. It's just figuring out what it is. Now, the only other type of prediction that we will have is for combustion. And you're going to have something like C4H8 plus O2. All right, combustion is always going to be attached to an oxygen. So when you see it like this, what is going to be your product? I told y'all what the products for this always is. There's two things. Think about photosynthesis. What are the products in photosynthesis? H2O and CO2. Sorry, respiration. What's the products in respiration? Photosynthesis is the opposite. All right. So anytime you have an organic compound plus oxygen, it's going to be combustion, and your products are always going to be H2O and CO2. Now, if we have now this is not balanced or anything like that. We could go back and balance it. So I have 4 carbons. That means I need 4 right there. I have 8 hydrogens. Here I have 2. So if I put a 4 there, that gives me 4 oxygens plus 8 oxygens. So that's 12. So I need 6 oxygens right there. All right, so that's a fairly easy one to balance. Now, the other type of combustion that you have is a metal combustion. Where you have something like magnesium plus oxygen. What would you predict the product of this one is? Well, but in this one, what's magnesium? When magnesium ionizes, what kind of ion is it going to form? Positive what? 2. So this one is always going to form magnesium oxide. And so to balance it, we'd go a 2 and a 2. All right. So a metal combustion is always just going to be the oxidized form of the metal. All right. So if we had something like iron 2 plus O2, predicting the products, it's just going to be FeO. And then we would do a 2 in front of there and a 2 in front of there. All right. So this is rust. All right. That's whenever you leave a piece of metal, a piece of iron metal out like a nail or something like that, and it rusts, that's what you're seeing. All right. This is also the compound that's in your blood, hemoglobin, that is really kind of the main contributor to why our blood is the color red that it is. Yes. This Roman numeral 2 is telling me that this is a +2 charge when it ionizes. All right. So some iron is going to be an iron plus iron 3, which is going to be a +3. Sometimes iron is just going to be iron 1. That's a +1. So I have to designate it for iron if I'm not giving anything else, because there are multiple answers on that one. All right. So let's go ahead and take out the review sheet and start looking at this. I apologize, I can't get this any bigger on my screen. That's why you have that as well. So don't try to read it off the screen as far as y'all are concerned. But let's go ahead and look at these and try to start working them out. So the skills that I'm going to ask you to be able to do on this is I want you to be able to write a word equation. I want us to be able to write a formula equation. I want us to be able to balance the equation. And this step 4, where it says confirm the law of conservation of mass, this is something that I'm going to show y'all now. If you're having trouble balancing the equations, this is kind of like a little way to cheat. Not really a way to cheat, but a method making this a little bit easier to see and understand. So you do not need a textbook for this. Let me try 100%. All right, there you go. All right, so this is a little bit better. All right, it says write the word equation for this reaction. And so the reaction we have a reaction with zinc with aqueous hydrochloric acid. Now, most of the time I'm not going to give you an acid because I haven't taught you to name acids yet. But if I give you an acid, I'm going to go ahead and tell you what the formula is. So this one happens to be HCl. So the reaction of zinc with aqueous hydrochloric acid produces a solution of zinc chloride and hydrogen gas. So writing the word equation, I'm going to start off with what's my first element or compound? Zinc. So I'm going to say zinc. What do I do next? Put a plus sign, and then hydrochloric acid. DROCHLORIC acid. Now, Since I put that it's aqueous, what should I do? Put an AQ. All right. Now, it says zinc in hydrochloric acid produces. So for produces, I'm going to draw my arrow. And then what are my products? Zinc chloride plus hydrogen gas. All right. So, zinc chloride, you can do it in one or two. I just forgot a C. All right. So real quick. All right. So go ahead and checking our formula. Chemical symbol for zinc is Zn. It's just zinc metal right now, so I'm not going to put a 2 or anything by it. I don't need to know the charge at this point. All right. The chemical formula for hydrochloric acid is HCl. And then it reacts to form zinc chloride. Now, if you look on the back of your reference sheet that you have at your desk, notice where on the column it says monatomic ions. Zinc is kind of a special metal. Even though it's a transition metal that can have multiple charges, zinc is one of those that really only has one charge, so it's just one you kind of need to memorize. So looking at that one, what is the normal charge of zinc? Plus 2. So how many chlorines is zinc going to react with? 2. All right. This is where the mistake would come in on this one a lot of times, that you end up with people thinking zinc chloride because I didn't state that it was just zinc 1, but there's no such thing. All right, so zinc chloride will form, and then hydrogen gas. Same thing. What do I need to do with hydrogen? I have to put a 2. Why is hydrogen diatomic? You can just say, all you have to say is Brinkelhoff or Magic 7. Those are the diatomic molecules. All right, so if I wanted to go ahead, this is a solid. I said this one was aqueous. This is also going to be aqueous. And this is a gas. All right. Now for balancing the equation, I'm just going to rewrite what I did before. All right. In order to balance this one, what do I need to do? All right. So zinc right now is balanced. Hydrogen is not, so I have 2 hydrogens on the product side. I need 2 here, so I'm going to put 2 there. When I do that, it gives me 2 chlorines. So do I need to do any more of this one? All right, so let me kind of show you how to use this box. It's not really anything. It's just kind of checking our work. So for this one, I'm just going to put the elements that I have involved. I have zinc. I have hydrogen. I have chlorine. All right. On the reactant side, how many zinc do I have? 1. On the product side, how many zincs do I have? 1. So that satisfies law of conservation of mass. We have 1 and 1. On the reactant side, how many hydrogens do I have? 2. How many hydrogens on this side? 2. And then chlorine, same thing. I have 2 chlorines on the reactant side, 2 chlorines on the product side. So is anything out of balance on this reaction right now? All right, so everything's in balance, so we did satisfy law of conservation. Um, if you're ever having trouble balancing an equation, it's good to make a little T-chart like this and just kind of see what's going on. Especially some of those reactions where you might have a polyatomic ion on one side and it splits up on the other side. Those are the ones where it gets kind of complicated that you have to track. Or if you have the same element that appears in more than one place on one side, it kind of causes problems. Now, just looking at this reaction, what type of reaction is it? Single, double, synthesis, decomposition, what? It's single replacement. All right? And it's single replacement because one metal replaces another. Flip over to problem 2. Problem 2 says we have hydrazine, which is N2H4, is used as rocket fuel. Hydrazine reacts violently with oxygen to produce gaseous nitrogen and water. I want you to go ahead right now. I want you to do the word equation and the formula equation. Take a minute or two to do it on your own, and then we will come back together as a class. So if you're watching the video, pause the video. You put water. Or the other thing that you could put is dihydrogen monoxide, something like that. All right, so looking at this, for the word equation, you should have hydrazine plus oxygen, or you could have put hydrazine plus dioxide, if you know already, yields nitrogen plus water. And then for nitrogen, you could also put dinitrogen. Either one of these would be correct and acceptable. All right, moving on to our formula equation. You should have N2H4 plus O2 yields to react N2 plus H2O. Now, go ahead, take a moment, recopy that statement down to number 3, and then balance it. If you have trouble balancing it, you could go ahead and start using the use this part. So I would go ahead and list my elements. I have nitrogen, I have hydrogen, and I have oxygen. Using that, just remember if you change it to one side, make sure you follow the changes on the other side. Because nitrogen is part of Brinkelhoff as well. You always put the subscripts. The coefficient is what I don't put. Name. What would we name this type of reaction? Is it? When we react something with oxygen, what is it going to be called? Combustion. All right, this is not an organic combustion, so the products are not H2O and carbon dioxide. This is more like the metallic combustion. It's just a combustion where we are producing, water is one of the products, but we ended up producing some other gas than carbon dioxide in this one. It's reacting with oxygen. Anytime we react with oxygen, it's going to be a combustion. We can't call it synthesis because we have 2 reactants, 2 products. We can't call it decomposition because we have 2 reactants, 2 products. We can't call it single replacement because we don't have a lone element, really. We have a diatomic molecule here. And we can't call it double replacement because it just doesn't. Double replacement is always ionic reaction. Is always an ionic reaction. So So the only category it really fits, or the category it most fits, is combustion. I would probably let you get away with single replacement on this one, just because of where it's happening, but it's not really happening in the right way. Hydrogen here goes from being a negative ion to a positive ion, and that doesn't, or it goes from a negative to a positive, so it doesn't really work for that. And that's why we end up with what we end up with. All right. And so the justification is combustion because it reacts with hydrogen. Because it reacts with oxygen, sorry. Charts. I can provide like a little scratch sheet with them that you can use. All right. All right, so go ahead, do steps 1, 2, and 3 for problem 3. All right, so going back for this one, calcium's a solid plus water, calcium hydroxide. Remember, calcium's a +2, so that means it's going to take 2 hydroxide ions in it. Hydroxide is one of those polyatomics. It's a -1. And then hydrogen gas. Hydrogen gas is an H2 because hydrogen is diatomic. Going from step 2 to step 3, where I'm balancing the equation, separated out my hydroxide in this case because I knew that I had hydroxide here. So this is going to make balancing a little bit easier if we treat the OH as a group. So this one I'm going to use my little chart to balance it. So looking on right now, and this is before I do any balancing, how many calciums do I have on the reactant side? 1. How many calciums do I have on the product side? 1. So right now, calcium is fine. Hydrogen. How many lone hydrogens do I have on the reactant side? 1. How many lone hydrogens do I have on the product side? 2. All right. So there's a problem here. And then I'm looking at this. How many hydroxides? I have 1. And then on this side, I have 2. So how do I fix this? If I put a 2 right here, then that multiplies this by 2, which equals 2. And that also multiplies this by 2, which equals 2. All right. So just manipulating this little part actually helps you fix the problem a lot quicker. All right. And what type of reaction would we call this one? Single replacement. A metal replaces, a cation replaces a cation. Moving on to number 4, I want you to try this one on your own. Try to go all the way through this one. So in a blast furnace, the reaction between solid iron 3 oxide and carbon monoxide gas produces solid iron and carbon dioxide gas. So go ahead, try to do it all the way through, and then we'll check our answers and discuss. So looking at this, we have some different things in here. This this mon in this description and the di in this description should give us an idea that this is covalent. So we're going to write the formulas based off of what we see. So starting with iron 3 oxide, that tells us that this iron has a +3 charge. Oxygen always has a -2. So when we crisscross it, we get Fe2O3. This is where one of the common mistakes is made in this problem. And then moving over, we have carbon monoxide. So it's just going to be CO, yields to form iron plus carbon dioxide, so CO2. All right. Moving down with the balancing. This one actually could be kind of tricky to balance. So I used the little chart here, but I want to show you what's going on. Because oxygen is in two different places, we actually started off, let's just start with iron. We have 2 irons on this side, and we only have 1 iron on this side. So in order to do that, I put my coefficient of 2. That fixed my iron, but then I get down here to oxygen where I had 4 on my reactant side, and I only had 2 on my product side. Well, if I tried to fix it to get 4 here by putting a 2, when I do that, if I only put a 2 in front of carbon here, how many oxygens do I actually end up with? 5. So 5 and 4 is not going to match up, so I had to do something different. So I just went 1 coefficient higher, so I put a 3 there. And when I did that, 3 times 2 is 6. And then the way that I got 6 here is I go 3 times 1 is 3, plus this 3 gives me 6. All right? No, we do not use the Roman numeral tells us what the charge is. All right? So what I'm saying here is I have 3 times 1 oxygen, so I have 3 oxygens here, plus 3 oxygens here, which gives me that number of 6. On this side, I did 3 times 2, which gave me 6. So at that point, now I need to just check my carbons. I had 1 carbon over here, so I put a coefficient of 3. That gives me 3. That gives me 3. So that is balanced now. So we have 3, 6, and 2. 3, 6, and 2 on this one.
I keep getting messed up with the formula equation part. Because, like, how do you know? Because it says 3 is for iron, right?
Yeah.
And then you put it for oxygen.
So, no, I didn't. That tells me that iron is a +3 charge. So now I'm crisscrossing.
Yeah, but why you crisscross on this monoxide and dioxide?
Okay, so algebraically, this has to equal 0. So 2 times 3 gives me a +6. 3 times 2 gives me a -2. So, 3 times 2 gives me a -6. So +6 plus -6 equals 0. So I have to do this to get this whole overall charge to equal 0.
But how do you know that? Like, how will we know that?
That's a rule that I gave y'all before midterm. When we were writing the formulas, when we were doing all of this, you just have to know that. All right? Shh. Guys. So remember, when writing the formula for a compound, algebraic sum of a compound, unless it's a polyatomic ion, has to be 0. So when you're reacting these ions, you're going to crisscross for that reason. You don't even have to really think about the math. It just works. All right? So if I bring the charge of oxygen down here and the charge of iron down here, it automatically gives you the formula. All right. Now, coming to this last part. I actually have trouble naming this one as any one particular type. It's actually a couple of different types. Um, if you were to do this and you said single replacement, I probably would have given it to you on that one, because what we do see here is this iron ends up by itself. We end up with a metal by itself, and that's the only thing that gives me any kind of clue what this is. This is an organic reaction, because carbon monoxide and carbon dioxide are organic compounds. Organics tend to start, they're some of the more difficult ones to balance. They're also some of the more difficult ones to identify what it is. And so, so for our explanation for a single replacement, I would just say that we see a metal by itself in the product. Now, I am sure that if I went and did the research, there is another name for this type of reaction. But for our purposes in this class, we can be satisfied with just calling it a single replacement because we have this lone metal right here. And that would be good enough justification for me and for what we're doing right now. All right. Any questions? So this is what I want you to do. On a sheet of loose leaf, write your name at the top. On a sheet of loose leaf, go ahead, write your name at the top. What I want you to do is, this is going to be the closure. I'm going to give you another kind of review sheet for the multiple choice questions that I would have on this test. But I want you to respond to these prompts. So based on your knowledge of writing word equations and balancing equations, respond to the following prompt in one or more paragraphs. First, I would like you to justify, think about how atoms rearrange into predictable patterns during chemical equations. So you've seen several different chemical equations by now in your homework packet and in this. So I want you to go ahead, look at those, and in your response, make sure you discuss the law of conservation of mass, why this applies to chemical reactions. All right, just a second. And then the second part is, I'm giving you a reaction between sodium hydroxide and hydrochloric acid. I'll go ahead and tell you, hydrochloric acid again is HCl, because we haven't done naming acids yet. So predict the product of a reaction between sodium hydroxide and hydrochloric acid. Oops, let me actually change that because that was my bell ringer. So let's do sulfuric acid, which is H2SO4. All right, so instead of hydrochloric acid, replace it with sulfuric acid. Guys, so predict the product of a reaction between sodium hydroxide and sulfuric acid, which is H2SO4. Your response should include a word equation, a formula equation, a balanced equation, and if you can, the physical states. What I will tell you is sodium hydroxide is going to start off aqueous. Sulfuric acid is going to start off aqueous. That's me getting messages from Mr. Young at robotics. because I only teach 2 periods. I'm leaving right after this one. Huh? It's the Ponce Trade Center. They already went to that one. Because it was right before midterms, and I couldn't justify in my head why I would miss 3 days right before midterms with y'all. No, I would have had parents calling me if I did that. That's on you, not on me. All right, I do want to make sure I do this before class is over. All right, so what am I expecting to have completed by Monday? The packet with all of the equations and all the practice work that we've done, whether it be balancing, whether it be writing the word and formula equations, the whole packet, pages 1 through 5, is due on Monday. The review sheets that I gave you, I am not collecting those for a grade. So the sheet with just like the little questions that I gave you towards the end of class, that one I'm not going to collect it. It would be a good idea for you to go through it at least. You don't necessarily have to write on it or anything like that, but it would be a good idea to go through it. The sheet that we worked on in class today, we did that in class, so I definitely won't collect that one. But I am taking this sheet, but I'm taking this sheet before the end of class today. Yes, the loose leaf that you're doing. So the only thing that I'll pick up before the test today is your homework packet that I put together for you. Test will be on Monday. We will get all of that together, and just be prepared. Go back through your notes. So I posted all the notes that we did. Go back, reread the notes, things like that. I will ask some multiple choice questions. The multiple choice questions are going to be, some of them are which one is balanced, which one is not. You'll have to be able to identify from that. And then other things that I'll ask are like kind of rules or steps for balancing, conservation of matter, those type of things. So just be kind of aware of that. The constructed response is pretty much all writing and balancing equations. There will be a few of them that are predicting. And the ones that I asked you to predict are going to be fairly straightforward. It's either going to be single replacement, double replacement, or a organic combustion. All right. NaOH. Yeah. All right. So any other questions about any of that? So by the end of class, I do want your part 1, part 2 of the closure turned in. For the remainder of the time, you can work on either your homework packet or just kind of doing the review.